Alright, so now I'm going to talk about inverse trigonometric functions. I'm going to start off with the inverse sine, which is 1 over the square root of 1 minus x squared. But when you're evaluating this derivative, you have to make sure that the absolute value of x is less than 1, because if it is 1, you'd be dividing by 0, which is no good. And if it were less than 1, you'd be taking the square root of a negative number. And with calculus, I don't think you should be worried about non-real answers. I don't think I ever use them in the class, so yeah, that's why this rule is there. And for arctan, the derivative of arctan is 1 over 1 plus x squared. Just to let you know, this notation and that notation are the exact same. I figured I'd just write both to let you guys know that. And this one, of course, has no domain restriction, because x squared plus 1 is never going to be 0, and it's never going to be negative. So that's why you can evaluate the derivative of this function at any point. And finally, the derivative of inverse secant of x is 1 over the absolute value of x, 1 over the absolute value of x times the square root of x squared minus 1. That's kind of messy. I'm going to write it again. 1 over the absolute value of x times the square root of x squared minus 1. And for this one, your x has to be greater than 1, because if it's 1, sorry about that, if it's 1, you'll be dividing by 0, and if it's greater than 1, you'll be taking the square root of a negative number, like I said before. So you may be wondering what the derivative of the other three inverse trig functions are, and they're just the negatives of these three functions here. The derivative of our cosine of x is just negative 1 over square root of 1 minus x squared, with the same domain restriction, of course. And the derivative of our cotangent of x is negative 1 over 1 plus x squared. Yeah, and the derivative of cosecant of x, our cosecant of x, is negative 1 over the absolute value of x times the square root of x squared minus 1, with the same restriction. So to remember these, which one's positive and which one's negative, the ones that start with the letter C are the ones that are negative. That's just what has helped me remember it, and it's pretty easy to remember that trick. So yeah. And of course, the ones that are negatives of each other are the one that's have the same sound to it, I guess. Like cosine is a negative of sine, cotangent is a negative of tangent, and cosecant is a negative of secant. Now you may be wondering how these rules come to be, and I decided that I'm going to be deriving one of these inverse trig functions for you, and that will be this arcsine. So we start off with y equals sine of x, and so to do the inverse, we just switch the x and y. So x equals sine of y, and we take the derivative of both sides. D over dx of x equals d over dx of sine of y. So this is just 1, and this would be cosine of y times dy dx, because we're differentiating y in terms of x. It's like implicit. So dy dx is equal to 1 over cosine of y. So next, cosine of y, we can rewrite that as the square root of 1 minus sine squared of y, because as you'll remember, there's a trig identity that cosine squared of a variable, say x, plus sine squared of x equals 1. So we just chaining this into that. So if we plug that in, we have dy dx equals 1 over the square root of 1 minus sine squared of y. But if you'll notice up here, we defined y as sine of x. So we can replace the sine of y as just x. So now we have 1 over square root of 1 minus uh, x squared. And just in case you might be confused, sine squared of y is the same thing as sine of y squared. So that's why we could just do the substitution of x as sine of y. I think that's all I have to say for inverse trig. Make sure you remember these, because out of all the derivative rules, I find inverse trig the hardest to remember. Like something like arc secant, arc cosecant, those are the hardest for me. So hopefully you can remember these easily, and yeah, bye.